Hi there, my name is Askari and continuing our SDL series. In this episode, I'm going to show you how to limit FPS in our game. So for that, I will have to make a falling animation of our player so you may be able to see the difference between a high FPS and low FPS. First, I will begin with some changing from the last episode. So I will go into our player class. Here I am passing rectangles, textures as arguments, and this way this is making copies of them and actually using them here. So if I pass something like texture, it will make a copy and then pass it to this function here. And which is bad if I am making like 100 function calls, then it is making 400 copies of each texture, rectangle and such, which is very bad. So we have to fix this. So what I figured out is we don't have to use them here. What we can do is simply use those calls instead of using them in our game loop. Use them here. So something like get texture here. This is very memory efficient. And get source and get destination here. So we have to change the pure virtual function in object class here. So I will make it this. In our background class, we also already have a function here. So we do not need this. And the implementation also, we don't need that either. H. Remove it, and now we will go into our game loop where we have used that. So let's hit and run and check if this is working. So this works great, and we save a lot of memory. Now we will create animation for our bird. Don't maybe it's not animation, just changing of position. We are not animating something. I think it's called animating. Well, anyways, in our player class we will create an update function, and in this update function I will change the position of our player. So I will write something like, in our update function I will write set source, and in set source I will pass similar to what we have passed earlier, 60 and 80. Set destination, and we will change this y position here to make it like we will increase it over the time, so it may look like the bird is falling down due to gravity or something. And to change that, we will make a function, we will make a private variable. I will call it gravity, and make sure to make it a double or float type, so such that we can use it precisely. I will make something like it will increase over time, so gravity is equals to gravity plus 0.5 each every time, and we will replace the 0 by gravity. So each time this function will run, our position will be changed, our player position will be changed. So let's implement this function. Go into our game loop, and in here we'll use player.update, and think that's it. Let's hit and run and check if this is working or not. So this works great, exactly as we expected. Now I will show you how to limit FPS. So for that I will go into a main, and first of all you need to understand what is 60 FPS. In 60 FPS, the difference between the last frame and next frame is 16.7 millisecond, and we get this by, let me show you in calculator. So is 1000 divided by 60, so it's 16.66 milliseconds. This is the time difference between the last frame and the next frame. If we multiply it by 60, just to double check, we will get 1 second. So this is double checking to be sure that our way of making this frame limiter is correct. Now what we have to do, I will make a double first here and a double last. In last we will store the last frame time. Let's initialize at 0, and here I will store the time in the first. Let's say, what's the function? SDL get ticks. This gives us time in milliseconds since our SDL library is included. So if we subtract it by, but before that I will store the first and last so that we have a time of two next frame and previous frame. So between here what I can do is I can check if, first of all I'm going to show you how much time there is currently between our last frame and the next frame. So I will write std cout right first minus last, and let's check how much time interval is between last frame and the next frame. So as you can see, it is mostly like 3, 2 and 4 seconds. So if we put this into a perspective, how much frames is that? You have to divide it by 60. So if I put like something 1000 and divide it by 3, so that's like we are getting 333 FPS, or sometimes the difference is 2. So if we put 1000 divided by 2, why I'm not sure why I'm even doing this, but it's 500. So we are getting around 300 to 500 FPS, and which is not optimal for our game because the difference make things complicated and we want a stable FPS. So what we will do, we will limit it to 60 FPS, and I already told you that 60 FPS is 16.7 milliseconds. So what I'll do is, if my first minus last is less than 16.7, this is in milliseconds, then what this will do is simply put a delay, and delay of how much? Delay of whatever is remaining to make it 16.7. For example, if it's 16.7 minus first minus last, so this will make it 16.7 millisecond in each frame. This way we will have a constant FPS in our game. Now if I run our game, my character will fall slower than before. So let's check. Because it's less FPS, so it's slower game. See how much slower and more consistent this is. So this is great. If we want to check how many FPS we are getting, I can print it out here. I will write as you can see we are getting constant 60 FPS here. So that is why our motion is so smooth. That's it for this video and I hope to see you in the next one. Thank you for watching. Bye.